Hi, everyone. I'm Calvin. I'm currently a security researcher at ERU. It's really my first time here. I've never actually given like a full-on talk before. I've always talked about stuff in bits, but this is actually the first time where I actually have to give a talk, and I'm really happy that I'm here. And thank you so much for Nick Zolo here and my manager encouraging me to actually give this talk. So I may mess up, and I was really paranoid that I might say things that might be wrong. So feel free to correct me. And I'm also very new within the Mac OS community. So I just want to give you a quick background of who I actually am, right? So I actually started myself with a bit of Windows reversing. So I played a lot of like malware analysis CTFs all the way to like just general CTFs in general. But also I came from a background of doing threat intelligence work. So I used to do threat intelligence for a bank before I got obsessive with deep and dark web, and then I did threat intelligence there, playing around with tracking DPRK and playing around with info stealer logs and doing some stuff that I probably should not be talking about because I might get arrested. So, anyways, I'm just playing. Yeah, that's not true. So there's a there's a few blogs that I documented, so feel free to join my Medium for my CTFs. In addition, on I've done some fun research using like ransomware negotiation chat logs, using stylometric analysis to basically pinpoint relationships between how each group kind of operates or talk to each other. So upcoming blogs, there is a malware model that I built for malware classification using the Bayes theorem. But anyways, I think we should probably go back to the Mac stuff, right? So currently, I realized one thing, and most Mac infections are kind of user assisted and kind of MCP allowed. It's not a 0-day I'm seeing. It's not a kernel exploit. It's a human clicked, pasted, or approved something. And I think like Apple does do a good job spending years of trying to harden the platform, and attackers are starting to stop fighting the OS, except if your name is Chaba or Mickey Jin. But I've also been seeing like a lot of social engineering on our end, right? There's a caveat, especially I feel like when you're writing detections, especially on the EDR side. Devs are running coding agents hands free. Every time we create a rule, a lot of these LLM models, Claude Code, for example, they generate all these problems of like potential false positives, and then eventually the sysadmins have to reach out to us and be like, "Hey, why did this rule kind of flag?" Well, it was probably used for malicious reasons, and it actually is probably used for malicious reasons because when we reverse the malware, it's really bad stuff that allows like privilege escalation, possible persistence mechanism, etc., and then eventually we have to whitelist it. But I do feel like personally that it is a problem that if we don't have the visibility to like look through like what Claude and the other stuff is generating, and it creates a lot of noise. So it's a big problem. But anyways, yeah, attackers are now caring more about Mac, and it's being more pushed towards enterprise fleets, and more users are using it in general. So macOS malware wasn't that popular back then, but now it's a lot more popular because everyone's using it, and the attack surface is becoming a lot more different compared to Windows. So everything follows come from one pivot. Anyways, so some recap mainly for me. I want to give about like the current security mechanisms that's in place for like trying to detect malware and like preventing malware from running. So the first thing is that there is gatekeeper and notarization. So it's like a first launch trust check that is triggered by the quarantine flag, and when it's present, it verifies the developer ID signature and the notarization ticket before the app runs. And previously there was like an easy way where you could like do the easy old kill the old control click bypass, and but now it's kind of gone, and you have to go through settings, privacy, and then you have to be like, okay, open anyway. And then I side quested. That's where I messed up because I was like, where can I wonder what are all the commands I could run natively to just like bypass and remove the quarantine flag. So these are like some of it, right? Easy. So these are like a few, and I was like, oh, let me see how that does. But anyway, moving on. So there's Xprotect. So Xprotect, it's a built-in AV. It's really, from what I've seen, it's like a Yara signature and a giant list, a P list of static indicators that are checked on launch, on modification, and on signature update. Plus, some behavioral detections are kind of in place. There's also the Xprotect remediator that are background activities that are they're known to like run like 20 plus something executables to remove known families. So interesting bit. I was watching a video on Cole Nakagawa's like Black Hat talk. And one interesting thing that he did talk about is that the macOS Provenance Sandbox, which is a type of gatekeeper, stamps a hidden provenance ID on every file a non-Apple signed app writes to. So the moment it's written, any file traces back to the app that is responsible. XVR kind of collects those tags while remediating, and then it removes the payload, it reads the provenance ID, identifying the dropping app, and then apparently I think it reports it back to the Apple threat intel. I may be wrong. Please correct me. And I think this could potentially be used to feed for the XProtect signature updates. There's also TCC, right? The consent gate, the full disk access automation, screen recording prompts. Interestingly, Chava Fitzel actually posted like a blog talking about how the location of where it was being put actually got moved within Golden Gate. So now it's in the place of /private/var/containers data protected systems /UID/data library. Blah, blah, blah. Okay, but it's changing. So one thing you also note that now it can't really be accessed even if you have full disk access, and it likely needs like a com.apple.private.security.protected system container entitlement for you in order to write to it. I think it might be because like a lot of people abused it for bug bounties. But anyways, and then lastly, there's also like the endpoint security framework, which is a support API, for EDRs to kind of build upon. So currently in the macOS 26.5 SDK, if you look at the type for the ES event type _T, there are currently 104 notify and 44 auth events. So auth events let you basically do stuff about it before the event actually proceeds, whereas notify is just it notifies you. So there's also like 9 ES reserve events that I kind of like saw, and apparently Patrick Wardle documented this and say that it might be something that's network connection related. So I was like, oh, that's really cool. There's also like additional other security mechanisms in place, such as like we see SIT, we see translocation, Amphi, but it's a bit too long to cover within this 50 minutes. So these are the kind of the main walls that I'm kind of seeing from it. So the hinge of this talk is that there's 4 bounded limits, right? Each maps to a technique that I'm about to show you. There's strong walls, but everyone has kind of like a human-sized door. One is that I feel like if there's a really new thing that's happening, right, especially with XProtect Yara, if signatures are broad, they could catch variants of known family, but not just the exact caches. But if there's a window until a rule is created for something, it's kind of hard for the XProtect Yara to detect. The other thing that I'm also noticing is like, okay, what if this is a Pi installer wrapper? So there was this one time I was reversing a Python malware. And I noticed one thing. It's because Pi installer macros are basically like zipped. And like whenever if you're writing a Yara for zip, you don't have access to the actual opcodes or the machine binary itself. You basically have access to the strings. So I feel like, what if you just change the strings? All right, Yara doesn't work anymore. RIP, right? The other thing I'm seeing is like natively is that behavioral detections exist, but it is thin. XProtect does flag some of the unknown malware behavior, but it's not of a full EDR grade monitoring. A novel loader that dodges the heuristic kind of sails through. And there's also the notarization part where it could be passed automatically. All right. It's signed, notarized malware kind of looks completely legitimate. And the big one is social engineering, right? So I was thinking about it, about like ways to bypass gatekeeper once again, and this is what malware is really just doing. It's a variation of all these same things. They're doing a curl. They're doing a curl plus X attribute remove metadata. That's kind of sus by itself because when you do a curl, there is no quarantine that's being triggered. You could sign it yourself, chmod plus X script base, and these don't change. So let me go through these 4 main things that I'm seeing, right? So number 1 is I'm seeing these click fix, these page that's like talking about, hey, these are new macOS like storage apps, or these are remediator apps. It's fake. Hey, you want to copy and paste this? You could use like an Apple script spawning. The number 2 could potentially be like a resign locally thing where they could curl a binary, do like a chmod plus X, and then do like a code sign, an ad hoc sign for it. And it is usually because the app's code signing cert has expired or been revoked. Sorry, my brain just got like lagged out. Yeah, so you can resign locally. It doesn't really separating ad hoc and signature. It is usually because the app's coding signature certificate expired, been revoked by Apple, or uses older signature format that Gatekeeper rules rejects. So you'll find this on deadfalls, home packages, third-party utilities. Not defeating Gatekeeper satisfying the separate signing rule on a file that was never quarantined. Okay. So number 3 is abusing the trust. Once again, just shipping like a notarized application. Maxing kind of did this last year in last December, and it's been reported by Jamf. And then lastly, the most popular one is the NPM compromises, where you could basically poison the entire supply chain. You skip the click fix thing, and you kind of just target one, the developers itself, and two is people who don't code, but they just use these agents directly, which makes the attack surface way, way more bigger. So yeah, so here are some example of malware dropped that we've analyzed. So the first one we kind of saw is that this comes from like a click fix. It was a AMOS sample that our team kind of pulled apart in March. So one uses click fix, and it was advertised through like a malvertising lure. And number two, it uses like a obfuscation. So while sorry. So while like I was running this, I identified it was using some kind of like custom string decryption routine to keep the real payload. So the first thing it does is that it runs like a anti-VM check, and then afterwards it uses like system profiler to check like if it's running QEMU, a VMware KVM, or they identify like Intel Core 2 strings, things that are kind of sus to say that this is sandbox, and then bail. And then number two, they kind of just like, compared to the old series, it's a bit interesting because I feel like they typically just put like a fake dialogue. But number one, this tries to like just run an empty password first and just be like, hey, can I like not hop in and just like button for it? And then apparently whatever works is kind of cached into like the home directory .pass. And apparently AMOS also allows for like reinfection. They don't care. I think when I was looking at Windows malware, they typically do like a create mutex to basically be like, okay, don't reinfect this again. But whereas for this one, they're like, I don't care, right? Money is money. I don't care. I'm going to resell all of this. And then the other interesting that I kind of saw is like the persistence mechanism, where they're just trying to like create like a com.finder.apple once they have like full access. And they create like a launch daemon. No, they create like a plist and put it in launch daemon, and then anything that executed is like within root. And then they create like another agent watcher to make sure that like if it ever gets removed, it gets placed back in again. And then this is like another one that I was seeing. It was more mimicking digit stealer, and this is actually a demo that I might show. So for this one, the entire talk of this concept is that this is actually an in-memory execution. So if you ever talk to any threat intelligence teams, they would always talk about IOCs, called indicator of compromises, and they would talk about like file hashes, things like that. Yeah, if it's in-memory execution, you can't really use a file hash for this. So what this basically does for this demo is, okay, I ran ESLogger, and what's gonna happen is that it. Sorry. No. Can I not edit this? Oh, I can. Okay, so I ran ESLogger. So we're gonna see the PID, the PPID, and the exec events. So here's the demo. The first thing that it kind of does is, one, it does the simple thing as what digitsealer does. It curls like a certain binary. It doesn't curl certain binary. It curls a JavaScript, basically. So when you curl the JavaScript and then you launch it with like a -L OSA script, it's in memory. It's not on disk. There's not really a file hash for it. So as you can see over here, running in memory, OSA script, there's no file hash. You can't really detect this. However, you can detect this in another way, which I'll say later. And then this is the other thing that I was talking about regarding like ad hoc code signing, but I think we kind of skip on that. But if we go back to it, we kind of see that we could still detect this though if we have access to looking at the PID and PPID, and a lot of this is just behavioral. So ILCs might not work, but behaviorals work way better. And then the last one I'm talking about, this one is an interesting one. So as a hobby for my work, I kind of built like an ML model, and then eventually one day I was triaging, and then I identified this malware called Star Agent. And since my malware ML model kind of like auto creates the Yara and does like an auto retro hunt, I was reviewing like the hunt results of it, and I was like, wait a minute, did I catch like a low detection malware? Oh my gosh! And I got really excited about it, but I also got like, so later on after I published this blog, Lobsec actually identified additional ILCs. For those who don't know Lobsec, Chris Lopez is a very famous like malware reverse engineer, and it was one of the first times where like I don't have to like do like a so he typically like gets contents from like the malware hunters, whereas I basically like raw dog it using like virus total and like my own queries, and I was like, oh my gosh, I caught something they didn't catch, and I messaged him on Signal, and he was like, yep, I'm very proud of you, man. I was like, did it, I did it. I was so proud. But anyways, so this is really interesting because we identified Star Agent through like it came from like a fake interview GitHub repo. So the repo itself wasn't actually bad, but what was bad was that it was actually using a typo squatted npm package, right? So it was okay. So the repo, it's a fake Web3 take-home project, a polished GitHub repo for like a smart contract engineer, Solidity contracts plus Nix.js front end, whatever. The repo is clean. The payload is within the tw-style.utils, kind of posing as Tailwind's typography plugin. And the real one is that when we look at the content itself, it's like a XOR obfuscated downloader that's kind of like appended into it. And what's interesting is that in Shai Halud, they do an npm install. This completely skips that. This just does an npm run dev or like an npm run build to. And we're just like, wait, so yeah, I mean, the point is like the recommendation of like the npm install dash dash ignore scripts that the everyone's reflex now to kind of like implement, it kind of doesn't do the same because it kind of run a different command. So I was like kind of interested about it. But anyways, I checked, I reversed the malware. It just fingerprints the OS and architecture, and then it seems like they're pulling a lot of different data. So they essentially like there's a looping HTTPS loop to like a cloud fronted domain, and then there's this command that's being run every 20 to 60 seconds or like 40 to 45 to 160 seconds, and it basically beacons like your entire Chrome extension inventory and your entire file tree of your home directory. So like you could just see like a massive blob of just like, oh, these are all the files within the system you have, and then they could basically make like requests to say like, oh, I want to run these certain commands on your system, all the way to saying like, hey, I want this file, like from based off what they're seeing. So that's pretty interesting about that. And here's the page, the hiring page that we kind of like found out about it. And yeah, so this is the GitHub repo. So it's pretty interesting. So from what I've been observing, it seems like within the macOS space is that every time there's like a new threat that's happening, Apple tries to patch it, and then whenever Apple patches that, another new circumvent just kind of like happens. So as we could see, December, MacSync goes sign and notarize, and then January, February, ClickFix started like getting ClickFix like kind of explode. With like Apple script stealers, and then during March, Apple kind of pushes back now, especially with their terminal like paste warning that ships with the macOS Tahoe 26.4. And quickly, Jam Threat Labs reported then that people are just like having it launch in AppleScript URL scheme, which launches the script editor instead of the terminal, completely sidestepping the warning. So detection-wise, right? Really easy, really simple. One, pin to behavior, have EDR that is being implemented. Be careful of what's on the FDA. Treat unexpected sessions and cookies reuse as MFA bypass incidents. And regarding like dependencies, keep everything defense in layer. It really like there are tools such as socket.dev that would like kind of check malicious packages. There's also like open source projects that kind of like keep track of like what are the current malicious packages available. But yeah, that's basically the same thing I said. So thank you. But once again, thank you so much. First talk, and thanks for helping me out.